In this video, we are going to talk about the acid-base equilibrium. And under this lesson, we will discuss the conjugate acid-base pairs and the concepts and calculation behind the Ka or acid ionization constant. So first, let's see what will happen when an acid reacts with water. When a normal acid reacts with water, it dissociates. It forms ions, positive and negative. So, based on this reaction, the given acid, when reacts with water, it forms a conjugate base and a hydronium ion. So why we term the anion as a conjugate base is because it has one less hydrogen and one more negative charge than the acid. Conjugate bases always have one less hydrogen and one more electrons or negative charge than the acid. And in this reaction, the water acts as a base because it's a proton acceptor. It accepts a proton and forms the H3O plus or the hydronium in this reaction. And the hydronium ion is a conjugate acid because when compared with water, it has one more hydrogen and one less electron. So conjugate acids always have one more hydrogen ion and one less negative charge than the base. We have already seen what will happen when an acid reacts with water, and now let's divide the acid into a strong acid and a weak acid. When a strong acid reacts with water, it completely dissociates. It is not reversible. It is irreversible. And this arrow implies its irreversibility. It always completely dissociates into ions, which means it fully breaks apart into its constituent ions without any remaining undissociated molecules. When calculating the pH of a strong acid, there is a simple mathematical equation. We will see that later. Now let's see the dissociation of weak acids. When weak acid reacts with water, it partially dissociates, not completely. And this indicates the reversibility of the reaction. When we say it's reversible, we are implying that the solution reaches to an equilibrium and the concentration of the reactant and product will not change with time. And both the reactant and product will also be present in the equilibrium solution. To calculate pH of a weak acid, we need to know the concentration of the acid and the Ka value. Ka, or acid ionization constant, is basically it's a measure of the extent at which the acid ionizes. It measures the dissociability of the acid. It also tells us whether the acid is strong or weak, which means it measures the strength of the acid. The value of Ka is almost the same at the equilibrium constant. So the formula is the concentration of the product divided by the concentration of the reactants. As you have learned in grade 11, water will not be involved in the formula, as pure liquids and pure solids don't take part when calculating the equilibrium constant. Ka value is constant but only for a specific temperature, which means it increases when the temperature increases, so that we can say it depends on temperature. And when Ka value increases based on the formula, we can see that the concentration of the conjugate base and the hydronium ion concentration will also increase. And the concentration of the acid, which is the Ha, here will decrease. So we can say that the value of Ka is directly proportional with the concentration of the hydronium ion, and that will increase the acidity of the molecule and decreases its pH because we are going to use the hydronium ion concentration when calculating the pH, right?